The ocean provides humans with a wide range of services: fishing, tourism, food, health and well-being. Yet human activities such as illegal and overfishing, climate change, ghost fishing and pollution are changing major components of the ocean and its functioning. So, how do we tackle these challenges to ensure the sustainability of our oceans? The United Nations have developed the Sustainable Development Goals, SDGs, a key piece of legislation that provides a roadmap to achieve ocean sustainability. Goal 14, Life Below Water, aims to conserve and sustainably use the oceans, seas and marine resources for sustainable development. Within this context, acoustic telemetry provides a great tool to meet the diverse targets of Goal 14. Fish are caught and undergo a small surgery where transmitters are implanted. With tracking networks across the globe, we are gathering vital information on marine life cycles and environments that can help us address many of the SDG targets. Acoustic telemetry can be used to measure the effects of marine pollution directly in the wild. It can measure pollutants like chemical spills and waste, boat noise, wind farms, fertilizers, light pollution and seismic noise, revealing the effects on animal behavior and disturbances to aquatic life. Protecting and restoring our oceans is key, but requires fundamental knowledge of habitat use and migration routes of aquatic animals, which can be determined with acoustic telemetry. At the same time, we can use acoustic telemetry to assess the effectiveness of restoration measures, such as artificial reefs, seagrass and coral reef restoration. Acoustic telemetry can also be used to monitor the effects of climate change. Here, ocean acidification is critical, but should be considered together with warming and deoxygenation. For example, shifting distributions towards the pole can be tracked, along with changes in behavior to avoiding warm and hypoxic waters, and responses to marine heat waves. Acoustic telemetry can provide information on natural mortality rates of fish and help delimit fish stocks. The SDGs wish to protect 10% of marine areas, though the aim is now 30% as per the Global Biodiversity Framework and High Seas Treaty. The design of effective marine protected areas relies on in-depth knowledge of species movements, home ranges, site fidelity, and the timing of various life stages, like when and where mating and spawning occurs. These can all be determined with the help of acoustic telemetry. Overfishing, illegal, unreported and unregulated fishing are major problems today that can be addressed using telemetry. For example, by assessing the post-release survival data of accidental bycatches or tracking the sound of boats, which can be transmitted in real time. Small nations have strong ties to the ocean. In the Pacific, the economic zones of these islands cover 40 million square kilometers of ocean, providing potential for sustainable local food and economic export to international markets. Monitoring these resources is key and can be achieved with acoustic telemetry. Seasonal trends in the migration of female fish can inform the closure of some fisheries at specific times, protecting the movement of spawning species. To ensure the future of the oceans, the United Nations has proclaimed the Decade of Ocean Science for Sustainable Development 2021 to 2030. The European Tracking Network is also recognised as an action for Mission Ocean, which aims to restore our oceans and waters. By using acoustic telemetry to reach the targets set out by the Sustainable Development Goals, we can contribute to the conservation and sustainable use of the oceans, seas, and marine resources.